Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today we're diving into a fascinating article by Terence Tao on how pure mathematics, specifically the landscape function, is contributing to lower electricity costs for households. It's a really cool story about the unexpected applications of abstract math.
That sounds amazing. I've always wondered about the practical applications of pure mathematics. So what's the core idea here?
Essentially, the shift to LED lighting has resulted in significant energy savings, already amounting to $14.7 billion annually in the U.S. in 2020. But what's truly remarkable is the role of the landscape function, a mathematical tool developed to solve complex equations related to semiconductor materials used in LEDs.
Wait, a mathematical function is helping design more efficient light bulbs? How does that even work?
Exactly. LEDs are made of semiconductor layers. To create efficient light, you need to control how electrons and holes recombine within these layers. The landscape function helps simulate this process. It's like having a super accurate map of the electron behavior within the LED.
I see. So before the landscape function, simulating LED behavior was difficult and expensive, right?
Precisely. Traditional methods were inaccurate, especially when dealing with the disorder in the semiconductor layers. This led to the green gap, a lack of efficient green LEDs, which hindered the creation of balanced white light.
Ah, the green gap. That makes sense. So the landscape function provides a more accurate and efficient way to simulate these complex interactions, leading to better LED designs?
Yes, it's a game changer. The landscape function essentially smooths out the complexities of the system, making the simulations much more manageable and accurate. This has allowed researchers to design more efficient green LEDs, closing the green gap.
This is incredible. So it's not just theoretical math, it's directly impacting our daily lives and saving billions of dollars in energy costs. But, how exactly does this smoothing work on a technical level? I mean, it sounds almost too good to be true.
It's not magic, but it's pretty close. The landscape function solves a related equation that effectively homogenizes the disordered potential in the Schrödinger equation, making it easier to solve for the electron wave functions. It's a clever mathematical trick that simplifies a very complex problem. Think of it as finding a simpler, equivalent representation of a complex system.
Okay, I'm starting to get it. So the landscape function isn't replacing empirical testing entirely, but it's significantly speeding up the design process, making it more efficient and cost-effective. This is a beautiful example of how seemingly abstract mathematical concepts can have profound real-world implications.
Absolutely. And the best part is that this is just the beginning. The article mentions that major companies are now incorporating these landscape-based methods into their simulations, promising even further energy savings in the future. It's a fantastic example of the power of interdisciplinary collaboration between mathematicians, physicists, engineers, and industry professionals.
This is truly inspiring. It shows how fundamental research, even in seemingly abstract areas like pure mathematics, can have a huge impact on society. It's a testament to the power of curiosity-driven research and its potential for unexpected breakthroughs.
Indeed. And it highlights the importance of continued investment in both fundamental and applied research. Thank you for joining us on Tech Bytes and News. We hope you enjoyed this deep dive into the fascinating intersection of mathematics and energy efficiency. Have a great day.
Bye-bye.